This is section 10.3, which is over the parabola. Here are the different objectives that we will see. And you're pretty familiar with the parabola and its graph, but we will identify some things that you have not seen before, including the directrix. We'll talk about parabolas opening right and left, which you might be unfamiliar with. So there are some new things, and in addition to that, some of their applications. So you may recall that the general equation, or the basic equation of a parabola, is here. And you may also remember that if the leading coefficient is positive, the graph will be opening up, whereas if the leading coefficient is negative, it will be opening downward. A parabola is involved in the conic sections group because if you dissect a plane with this cone, once again, you get this parabola here. We'll find that all points on a parabola are equidistant from a line, that's called the directrix, and a fixed point, which is the focus, which is inside the parabola. So on this page, we'll talk about some basics of the parabola. One thing I would like to mention is that we will have an axis of symmetry, which is nothing new. So the right-hand side is equivalent to the left-hand side. We will identify the focus of a parabola, which is inside the parabolic shape. And one thing that is new is this distance between the vertex and the focus is P. And that same distance from the vertex outside of the parabola is the directrix, and that is a line. Okay, the vertex is this point here, and it will either be a maximum or a minimum, or the furthest left or the furthest right point. This here talks about basically the definition. You can read through this here. The focal length is this here. This will basically help us identify how skinny or wide our parabola is. And that focal length is represented by the absolute value of P. Okay, so like the other conic sections, here we're going to start with a vertex at the origin. We will have a y-axis of symmetry. So it's going to either open upward or downward. So it's not a hyperbola. It'll either be like this or like this. And it will take on this form here. So the x value is squared, and then we will have 4p times y. This 4p is going to help us identify the shape of the parabola. On the other hand, we'll have a y-axis of symmetry, an x-axis of symmetry. So the parabola will either open left or open right. If we have y squared, and then that will be equal to 4p times x. I want to remind you that the directrix is always an equation, so it should be written as an equation. And it will either be y equals or x equals, depending on how this graph opens. And then the same thing with the axis of symmetry, that should be an equation as well. Here is a bit of a graph kind of illustrating what's going on. So here, if we have a y-axis of symmetry, if this value is positive, it will be opening upward. On the other hand, if we have an x-axis of symmetry, if this value is positive, it will be opening right. Here is the opposite. If this is negative, we'll be opening down, or if this is negative, we'll be opening to the left. And hopefully in these images, you can see that the directrix is always on the outside of the parabola, whereas the focus is on the inside. So the way we write the equation of a parabola is going to be a little bit different. So this format is something new, and again, the reason it's helpful to write it this way is because this here is going to help us identify the shape of the parabola. So let's just jump into some examples. Here, we're given this equation of a parabola, and we are asked to find the focus and the equation of the directrix. So I've gone ahead and graphed this for you here, and I want to remind you that the focus should be somewhere in here, whereas the directrix should be somewhere out here. So since we have the equation with y squared is equal to 4px is the general form. Well, in our case, 8 is replacing 4p. So we can go ahead and say that 4p is equal to 8. We'll go ahead and divide both sides by 4 and find that p is equal to 2. Which means from our vertex, the focus is 2 units to the right. In this particular case is the focus, and the directrix is 2 units to the left in this case. So this is the directrix. So our focus has the ordered pair 2, 0, and our directrix has the equation of x equals -2. I know the equation is x equals -2 because this line goes through the x-axis at -2. Go ahead and pause this and give this a try. Okay, so here we have a different equation. Now we have x squared. So remember, our parent equation is x squared equals 4py, which means 4 is replacing 4p. So I can go ahead and say that 4p is equal to 4, which means p is equal to 1. Now, it might be helpful to identify what this graph looks like. Because this is positive and x is squared, I know that this is a parabola opening upward. I also know that the vertex is at 0, 0. So from here I'm going to go up 1 unit for the focus. So my focus is 0, 1. And from my vertex, I'm going to go down 1 unit to get my directrix. So my directrix is y, because it goes through the y-axis, is equal to -1. We're going to be doing more of this as we move on, so if you don't quite get it yet, I think some more examples should help. Okay, so sometimes we want to determine how wide the parabola is going to be. And the way we figure this out is by a specific line segment called, this is always enjoyable, the latus rectum. Yes, I know. The length of the latus rectum is called the focal diameter, and the focal diameter is equal to the absolute value of 4p. So here would be the focus. This is the focal diameter. So this is the absolute value of 4p. This length will help us figure out how wide the parameter, how wide the parabola is. Okay, so let's put all of this together and do this example. So we want to identify the vertex, the focus, and the focal diameter. Then we also want to identify the endpoints of the latus rectum and come up with the equations for the directrix as well as the axis of symmetry. So there is a ton going on in this example. Okay, so let's just take some baby steps. The first thing I notice is that I have x squared, which means this parabola is either going to open up or open down. Because this is positive, this parabola should open upward. Okay, well, this 16 represents 4p. So if 4p is equal to 16, I can go ahead and conclude that p is equal to 4. That means once I identify the vertex, I will go up 4 units and down 4 units to find the focus and the equation for the directrix. From here, I have nothing attached to the x or the y, which means my vertex is 0, 0. So that is right here. We know that p is 4, so I'm going to go up 4 units, and this is my focus. So my focus has the ordered pair 0, 4. From my vertex, I'm going to go down 4 units to get my directrix. My directrix has an equation of y equals -4. It goes through the y-axis, so it's an equation of y equals. Now, if I wanted to just make a gentle sketch, I could, but I have enough information to identify how wide my parabola is going to be. And that is my focal diameter. Recall that my focal diameter can be found by taking the absolute value of 4p. Well, this is 4p, and the absolute value of 16 is 16, which means the length through here has to be 16 units. If I split that in half, I'm going to go to the right 8 units, and to the left 8 units. And this is the focal diameter. So this will help me identify the shape of my parabola. The last thing I want to do is identify the endpoints of my latus rectum, which would be here and here. So from the vertex, I go to the right 8 units, up 4, and I also go to the left 8 units, up 4. So those would be my endpoints. The last thing, sorry, my axis of symmetry goes through the parabola here. So it is x equals 0. And that concludes this example. Let's do the same exact thing with this equation. Now, looking at this, I see I have x squared, which means this will be a parabola opening upward or downward. Because this value is negative, I'm going to have a parabola opening downward. In this case, 4p is equal to a negative 8, so p is negative 2. So if you want to begin sketching this, you certainly can. I don't have anything attached to the x or the y, which means the center, the vertex of my parabola is 0, 0. So that's going to be here. We know this is going to open downward, so this is going to tell me that my focus is down 2 units, so that would be 0, negative 2. On the other hand, my directrix will be up 2 units, and will be this line here. It goes through the y-axis at 2. All right, my axis of symmetry is what breaks this parabola in half. That is going to be x equals 0. My focal diameter helps me identify the width of this parabola and is found by taking the absolute value of 4p. So the absolute value of negative 8 is 8, which means this length should be 8, and it is symmetrical. So I'm going to go to the right 4 units, and I'm going to go to the left 4 units. That will also give me the endpoints of my lattice rectum, which will be positive and negative 4, comma, negative 2. And then I can go ahead and sketch in this parabola. Not so bad. Here's another example, and this one is a little bit different because we have a coefficient here. And in this case, we're going to want to try to avoid this if possible. So in order to eliminate that, we're going to divide everything by 3. And this will give me the equation y squared is equal to negative 12x. Now this one's a little bit different because now we have y squared, which tells me my parabola is going to open right or left. Because this is negative, our parabola is going to open toward the negative numbers. So our parabola is going to be opening to the left. So let's go ahead and get started and identify all the good stuff regarding this parabola. So the center is 0, 0. All of these will, not the center, I'm sorry, vertex is 0, 0. All of these will have a vertex of 0, 0 for now. Then 4p is equal to negative 12. So p is negative 3. So we will go to the left 3 units to get my focus. So the focus is negative 3, 0. We will go to the right 3 units to get the directrix. Which is an equation of x equals 3. The axis of symmetry, in this case, is the x-axis, which is the equation y equals 0. We now want to identify how wide this parabola is, so we are going to use the focal diameter. Remember, the focal diameter is the absolute value of 4p, which in this case is the absolute value of 12, or 12. This means this length needs to be 12. Split that in half and you'll get 6. So up 6 and down 6. Here. And here. And while you're at it, you can find the endpoints of the latus rectum, which are -3, -6, and -3, 6. Then go ahead and sketch in your parabola. There you have it. All right, now we're getting to the good stuff where the vertex is no longer at 0, 0. So now we're going to take this parabola and shift it around. And as you can see, now we have some values attached to the x and the y. And everything else is the same except for where the vertex is. We'll still have a 4p here. Still horizontal axis of symmetry, vertical axis of symmetry. So everything is really the same. So here is a picture. Again, it will kind of explain when it opens up, down, left, or right. So to graph a parabola that has a vertex other than 0, 0, first you're going to want to locate the vertex. Fine. Then it's helpful to identify which way this parabola is going to open so that you have an idea of what you're working towards. And then, you know, all the steps are really the same. Find the focus, the directrix, the endpoints, and then you can go ahead and sketch. So it's not too difficult as long as you continue to follow the same steps. So let's give it a shot. All right. So we can see that the y value is squared. If the y value is squared, that's going to tell us that our graph is either going to open left or open right. Because this is positive, our graph is going to open to the right. Okay, so our parabola should resemble this. Now, I apologize, fireworks, okay, hang on. Fireworks are beginning to go off and my dog is afraid. So please bear with me as I get her to calm down. This is a very professional video, so thank you for your patience. Okay, we need to identify the vertex. Now, remember the vertex is HK, and H always goes with X, and K always goes with Y. And it's always the opposite of the sign you see. So, our vertex will be -2, 5. Let's go ahead and graph that now. Here is our vertex. Okay, now 4p is equal to 8 in this case, so p is 2. So this is my focus, which has the ordered pair 0, 5. My directrix is here, which will have the equation x equals -4. Then our focal diameter is the absolute value of 4p, which is 8. So I'm going to split this in half, which is 4. So from my focus, I'm going to go up 4 and down 4. And this will give you the ordered pairs of the endpoints of our focal diameter. And you can go ahead and identify those. And here is the shape. More fireworks. Let's give this one a try. Okay, so looking at this, The y is squared, and we have a negative value here. So our graph should be opening to the left. Our vertex is at +4, +2. So we can go ahead. This is just going to be a brief sketch. So that will be here. All right. 4p is -8, so p is -2. So we will go to the left 2 to get our focus. That will have the ordered pair 2, 2. And we will go to the right 2 to get our directrix. And this goes through the x-axis at 6. Then my focal diameter is the absolute value of -8 or 8. So from my focus, I'll go up 4 units and down 4 units and see this shape here. Here, my axis of symmetry cuts this in half. So my axis of symmetry will be y equals 2. Similar to the other conic sections, we will want to put this equation in standard form. The thing that's different here is that you will have 2 values for either x or y, and then 1 for the other variable. So you still want to complete the square, but the thing that's different is that both of these will be moved to the right because we just want to group the like terms. So we will have 4y squared plus 12y plus a special little number is equal to a -16x plus 71 plus our special little number. Just like before, we're going to take out our GCF, leave room for our special number, and then over here, there's nothing we can do at this point. So let's find that special little number, and we'll do that by taking 3 divided by 2 squared, which is 9/4. So this is 9/4, but remember this number is really 9/4 times 4, which is 9. So this is a little messy because we have a fraction, but it's certainly not the end of the world. Remember, this factors into something times itself. In this case, it's y plus 3/2, quantity squared, is equal to, combining these like terms here, we'll have a -16x plus 80. All right, now over here, this is a little messy. And so what I'm going to do is I'm going to factor out a GCF over here. So I'm going to leave this as is and factor out a GCF, which I'll take out a -16. So I'm left with x minus 5. Now the right-hand side is looking good, but I don't want this here, so I'm going to divide both sides by 4. So these will cancel out, and I'm left with the quantity y plus 3/2 squared is equal to, this simplifies to a -4 times the quantity x minus 5. And this is the equation of our parabola in standard form. Again, just like the others, we'll have to do a little detective work. So we want to determine the standard form of the parabola given this information. So let's just sketch what we have. we know the focus is negative 5, 8. So let's just say this here is the focus at negative 5, 8. And the directrix is at y equals 6. Well, if this is the case, the vertex has to split these two. So the vertex is right here. So this tells me that my vertex is at negative 5, 7. We know this is going to open upward because the focus has to be on the inside, which means 4p must be positive. Additionally, we know this distance is 1, so p is 1. So the standard form of a parabola is the quantity x minus h squared is equal to 4p times y minus k. And this is when the parabola opens up or down. The x has to be squared. So let's plug in what we know. We have x plus 5 is equal to 4 times 1 times the quantity y minus 7. So the only thing I need to do to clean this up is just write this as 4, and then this would be my equation. Done. I'm going to conclude this section by doing one example of an application of parabolas. And this is a very famous logo for McDonald's, one of my kids' favorite places, which I can hardly believe. Anyway, we have these two parabolas side by side. So you can go ahead and pause this and read through this a little bit if you'd like. But from this, I've gone ahead and placed this logo right on a coordinate plane. And we know that these maximum values are at 2, 8, and negative 2, 8. And we're going to take this onto the next slide, and we're going to find the equation of each parabola. I'm going to call this the left parabola and this the right parabola. Okay, so let's go ahead and do that now. Okay, so again, negative 2, 8 and 2, 8. All right, now these are parabolas opening downward, which means we're going to have x squared. So the left parabola has this vertex. So writing that, I'll have x plus 2 quantity squared is equal to 4p times y minus 8. So now what I need to do is I need to identify what p is. And remember, this helps me identify how wide the parabola is. So what I can do is I can choose any point on this parabola, any point I want. And if I can plug that in for x and y, my only missing variable will be p. And then I'll be golden, pun intended. So I'm going to choose the easiest ordered pair, which is 0, 0. And if I plug that in, I have 0 plus 2 squared, is equal to 4p times 0 minus 8. And again, I have chosen 0, 0 because I know it is on this graph. And as long as I pick any point on this curve, I'm good to go. So simplifying this, I get 4 is equal to 4p times negative 8. Doing a little bit of math and getting p by itself, I find that p is negative 1/8. And that p should be negative because this graph is opening downward. So now all I need to do is take this and plug this in here. So my equation is now x plus 2 quantity squared is equal to 4 times negative 1/8 times y minus 8. And as long as I simplify this, my equation is done. So the equation of the left portion is x plus 2 quantity squared is equal to negative 1/2 times y minus 8. Here is the equation of the left parabola. The right parabola is the exact same thing with one difference, and that is the x value of the vertex. Everything is done the exact same way, but you will find that instead you'll have the quantity x minus 2 squared. This is the only difference. Is equal to, again, a negative 1/2 because it's opening downward and has the same width, and y minus 8. And that concludes section 10.3.